Well, good morning all. It is Friday the 31st of January 2025 and I wanted to just do a little tutorial on hot water heat up times. Gets a lot of confusion from people as to what size of hot water cylinder they would require, what the time is they would do. A lot of people are sizing heat pumps now just on hot water demand, which I can kind of see the logic in that a lot of the time, especially if you've got high usage of water within a property. There's a couple of things that need to be sort of cleared up first, I think, because the British standards changed, I think it's about 18 months ago, maybe 2 years ago, something like that, from BS 1566. Now, 1566 was the standard for hot water coils and that sort of stuff, so actual heating coils. And this needed to be adjusted really, because a lot of manufacturers, I think some still do, they will size the heat transfer coil, so they'll size the heat exchanger, if you like, the coil inside a hot water cylinder by its square meterage, where now that has been updated now, and generally most manufacturers now will size it by kilowatts. So they'll give you a kilowatt output of the coil, which obviously makes it an awful lot easier for us doing these calculations. So again, I try to just use software tools in all my design work and make the process of calculation as easy as possible. So what I do now, I've been using a little website, and again, I don't endorse any of these websites at all. I don't get paid by any of these people at all. But this is what I found quite easy. There's a little website, and it's called myboiler.com, and there we go, there straight up there, and they do a hot water recovery time calculator, but also a recovery time in kilowatts required. So we have a couple of rule of thumb figures which we've been working on for many years now, and I can still see why we do it, but we want to question that and challenge the narrative as always. Generally, for high output heat up times, gas boilers, that sort of thing, for hot water cylinders, you would generally be looking at a storage capacity of about 35 litres per person per day. And if you've got slower heat up times, like heat pumps would be, because they're lower outputs of kilowatt rating within them, you'd be looking at a storage of around 45 litres per person per day. So if we work on those bases, and then we're going to discuss after that priority hot water. So in other words, what does priority hot water mean? It means that when there's a call, so if you've got a sensor in your hot water cylinder, and as soon as water is drawn off of that hot water cylinder, that temperature sensor recognises that water's been drawn off, and it will then automatically send over the signal to the heat source to ramp up to maximum kilowatt outputs. A diverter valve will move across, and it will just generally put all of that heat source power into the hot water coil to recover it as fast as possible. And that's the general rule of thumb of what we kind of like to use. And what it does, it allows you then to use lower capacity hot water cylinders, so less stored water, if you calculate it out correct. So this is very simple to do. A couple of bits we need to do, because this was brought up by somebody on social media a couple of days ago, that what does the 14.3 represent within your calculation? So if we zoom in here, you can actually just see what it means. 14.3, basically all it means is your time in seconds divided by the specific heat capacity of water, and this is rounded up to 4.2. Obviously specific heat capacities change with temperature, but for our basic calculation, the general rule of thumb is to round everything up to 4.2, and that makes sense. So 60 seconds or 1 minute divided by 4.2, that gives you your 14.3 constant. So when you're trying to actually calculate the time, it's the volume of water times your delta T divided by 4.3 times your power kilowatt. Okay, and that will give you these answers. So if we just pull out here to this, so if we say we've got, let's get a little calculator up, and if we say we've got, I don't know, 5 people, so a couple, 3 kids or whatever, 5 people living in a house, and they've got a gas boiler for argument's sake. So we'll say 35 litres times 5 is 175 litre hot water cylinder. So we've got a 175 litre hot water cylinder. Let's put that volume in there, 175. We are looking at a temperature rise. Let's just say if that's discharged all the way throughout the day, you've probably got still 10 degrees of water still sitting in the tank. But that's going to be something that you'd need to ascertain. But if we say that our delta T, we want to heat up to 55 degrees, or even 60 degrees. So if it's 60 degrees, we'll leave that at 50, because that'll be 60 degrees minus the 10 degrees, which gives you that delta T temperature rise. And let's just say we've got a 24 kilowatt boiler. So a 24 kilowatt boiler. So there it is. That will heat that hot water cylinder up in 25 minutes. So 25 minutes. I mean, that's you know, that could be afforded then to be heated up overnight. Now, what if that was a let's get the calculator back up again, just so we're all clear. And let's just say that was a heat pump, and we got 5 people. So we go 45 litres per person per day times 5. Okay, so that's a 225 litre cylinder. And let's put that down into the box. So 225 litres. Again, we're going to raise up to say 55 degrees on this. So we'll say that's our recovery. So we'll say 45 of our delta T going across. But we've only got an 8 kilowatt or maybe even a 6 kilowatt heat pump. 6 kilowatt heat pump. So even overnight with hot water setback, it's going to get recovered fully with that in 118 minutes. So I think people tend to kind of over egg all these requirements, but you need to make sure that, obviously, as we just explained, that your hot water cylinder has a 6 kilowatt coil. Doesn't matter if it's slightly higher, but as long as you match those, these are going to be the recovery times that you've got. Now, there's a couple of things and caveats here that I like to discuss with these. If you've got a large amount of stored water, for argument's sake, it could be in a community dwelling or something along those lines, you would generally be putting in a destratification pump. So that would actually literally pull the hot water from the top of the cylinder and pump it back into the bottom of the cylinder and mix it as it heats up. So you get a full spread of heat and a full tank of hot water at the same temperature. These are really quite good in large volume places, because they cut down the size of the cylinder that is required. And obviously, what happens when you start putting cold water into hot water, it develops what is called a thermocline, and that will actually start to mix the water. You will recognise a thermocline if you go swimming in the sea or something like that. You'll suddenly swim into a very cold section or into a warm section, and that's the thermocline in action. Same thing happens in a hot water cylinder. But let's have a look and say that we don't have any destratification pump on the hot water cylinder at this time, and our tank sensor for priority hot water is about a third of the way down the cylinder, as they generally are. You're pulling off. Let's just say you're going in to have a shower and you've pulled off 30 litres of water out of that cylinder. So we need to recover that 30 litres, and we've got a 6 kilowatt heat pump on priority hot water. So we've now only pulled off 30 litres. So let's pull up 30 litres, and we want to raise that. I would say again it's coming up to around that 45 degree mark. I mean, 30 litres of that is 15-minute recovery time. 16 minutes almost, 16-minute recovery time. That's, to my mind, that's not something that anybody would need to worry about. And so what we could actually say is, then, well, do we actually need to have that full 225 litre hot water cylinder? Not everybody's going to be having a shower at exactly the same time, but you might say that 2 people are, in which case that might be 60 litres that are being taken out of a cylinder. So there's 60 litres that are being taken out of that cylinder. What is the recovery time on that? And as I say, this is not an exhaustive tutorial on this. We can go into an awful lot more detail on this, but it's just a very quick, short video to try and explain this. But you're still only looking, with 2 showers that have come off, you're still only looking at a half an hour of recovery time. Now, in a house that loses an average in the UK, which is, they're quite poorly built properties in the UK, we say we lose 3 degrees in every 5 hours, which is generally the rule of thumb. That half an hour of priority hot water with 6 kilowatt going into that hot water cylinder, presuming there's no defrost cycles going on at that same time, would recover that in no time, and you wouldn't actually see anything. So you're going to get longer run times. So what I say is that get this myboiler.com website up, have a play with this with your own, and then get some ideas about how you would like to size your hot water cylinder using those rule of thumbs. See what space you've got and see what your recovery times are, and you make an engineering decision about what size you're actually going to use and the recovery times that you've got. So guys, I hope this tutorial helped you, and any questions, obviously put them in the comments. Please hit the subscribe button, that'll really help me out, and we'll be able to do a load more of these then for people. So guys, have a great day. Many thanks. Bye bye.